Let's take a point in space and let's see how many lines can pass through that point. In fact, you will observe there can be infinitely many lines, right? What is the difference among these lines? You'll see they're passing through the same point. There is the point, but their direction is different. Means a line can be uniquely identified if it passes through a point and has a unique direction. This is one way we can identify a line. Also, if a line passes through 2 points, yes, let's draw a line first. This is a line, and you can take any 2 points on the line, this point and that point. Then also it is a unique line. So there are two ways to identify a line in the space that is uniquely determined. Just like an individual has a unique address, the line also has a unique address, and it can be identified if you know a point through which the line is passing, and then the direction in which, number one, and number two, when you know that these 2 points through which the line is passing, right? So there are two ways to determine a line uniquely. Let's see the first one. Equation of a line we would derive passing through a given point A and parallel to a given vector B. So let's first draw this Cartesian system. Let's say this is x-axis and y. X and y are mutually perpendicular. The third, because we are talking in third dimension, the third axis would be perpendicular to both x and y. We cannot show it in two-dimension figure, so we are slightly drawing it this way. Remember that this is perpendicular to both x and y. In fact, all these three, this is x coordinate, here we have y coordinate, and this is z x-axis, I'm sorry. This is x-axis, y-axis, and z-axis. So they are mutually perpendicular. Let's take a point somewhere there. Let's say this is a point A. All right, this is a point A. And we are also given a vector. Let's draw a vector V. Vector B. This be a vector. This should be a vector, so we should write an arrow like this. So this is a vector B. We put an arrow over this letter, right? So this is vector B, and we want to draw a line parallel to this vector. So, well, we will draw this line parallel. Let's go from there. Does it look like parallel? It should look like parallel. At least it should look. Yeah, is it looking parallel? No, you can draw it. Should look parallel. Somewhat. Is it looking parallel now? No, it's opening up. Okay, we'll assume now it's much better. We'll assume that this is parallel, this line and this vector are parallel to each other, okay, passing through a point. So we would like to draw this vector. This point is origin. From origin to A, this we can represent by small vector A, small letter and A, and we can take any point on the line. That is a general point. Let's take this point, and we want to join that point from origin, and that vector is a general vector which we represent by letter R vector. Okay, this is the point P over here. Now, since this is vector B, which is parallel to line L, our line L is this. So B is parallel to L. Can we find AP vector here? Very easily we can find AP vector. AP vector would be lambda time B. This is from the definition. Parallel vectors can be written. If B is this much, AP would be a part of B. The direction is same. So we say lambda time b, where lambda is a constant. So this much we are saying AP is lambda b. So that is from direction from A to P, AP vector. Now we would like to use here triangle law of vector addition. This point over here is O, origin. So our in the triangle OAP, you can say OP vector would be same as OA vector plus AP vector. OA plus AP is OP. And OP can be represented by small r vector is equal to OA is a small a vector and plus lambda time b. So this would be your vector equation of a line passing through a point and parallel to a given vector b. It's passing through this point and parallel to vector b. So it's a very easy, but you must draw the diagram and then write this equation, vector equation of. Once you write the vector equation, you would like to change this into Cartesian. So we are going to change this into Cartesian now. Vector r is a general vector. So vector r can, let's write it here. Your vector r can be written as x time I, xi cap plus y j cap plus z k cap. Vector A, that point would be given x1, y1, z1, something like that, okay? Your point A would be x1, comma, y1, comma, z1. That means vector A is going to be x1 I cap plus y1 j cap plus z1 k cap. Is that fine? Now, you have R, you have A. Also, you would be given this vector B. Vector B, let's say this is AI plus AI cap plus BJ cap plus CK cap. That is vector B. So we'll simply substitute these values here. So we'll get in place of R, we are going to write I cap plus Y J cap plus Z K cap is equal to A. A is x1 I cap plus y1 j cap plus z1 k cap plus lambda time. B is AI plus, right? AI cap plus BJ cap plus, okay, excuse this, CK cap. Sorry. We want to now write, we want to find the coefficient of I, j, k and equate them on the left hand side and right hand side. So for that, let us keep the left hand side as it is, which is x I cap plus y j cap plus z k cap will be equal to, can we bring the coefficient of I cap together? So it will look like x1 plus lambda a I cap plus y1 plus lambda b. This would be j cap plus, let's write it there, z1 plus lambda c and k cap. I would create some space up there so that we could write it clearly. And this means now we can equate the coefficient on the left hand side and right hand side. Yes, that will give us x is equal to, see the coefficient of I cap here and the coefficient of I cap here. So x is equal to x1 plus lambda a. Can you find the value of lambda from there? Of course, yes. So we get x minus x1 divided by a is equal to lambda. Yes or no? we are getting the value of lambda by equating coefficient. Same thing we are going to do with the y, you see here, yj. So we are getting y is equal to, the coefficient here is y1 plus lambda a, y1 plus lambda b. That means we will get y minus y1 over b. That is also lambda. Yes. Can we extend the same logic and say that this even the third one, let's write with this color here. Okay. We can equate now this zk, and here we have z1 plus lambda c. No? So can we say z is equal to z1 plus lambda times c? That will give us value of z minus z1 over lambda is equal to, okay, over c is equal to lambda. You see that lambda is the same constant that we used here. That should be equal. The value of lambda is equal, you know. So that means, can we group them together? Can we write x minus x1 over a, y minus y1 over b? This, this, and this are equal. So what we are going to write is, in Cartesian form, x minus x1 over a is equal to y minus y1 over b is equal to z minus z1 over c. Now this is changed into Cartesian form. X1, Y1, Z1 is the point A which was given is x1, comma y1, comma z1, and the vector B, right? Vector B was A I cap plus B j cap plus C k cap. Is that fine? So A and B are given. You can directly also write this in Cartesian form. Also, we know that these ABC and direction, these are called direction ratios, and they are proportional to direction cosines. You know, direction cosines are represented by L, M, and N. So we can also write our equation when direction cosines and one point is given. So in place of A, B, C, we can write x minus x1 over L is equal to y minus y1 over M is equal to z minus z1 over N, where L, M, N are direction cosines. About direction cosines and direction ratios, we have already learned. So direction cosines are proportional to this. Like, I mean, you can multiply these three equations. I mean, these three terms are equal. So you can multiply here by lambda, lambda, lambda. Then also it will be equal, no? You are dividing every term by 3. So we can replace this lambda a by L, lambda b by M, lambda c by N. So means we can use any one of these two equations to find the Cartesian form of the any line when we are given one point, and we are also given a vector through which, through which a point through which the line is passing, and a vector which is parallel to the given line. So it's very easy and convenient. We would like to take one example and to see how it works. There is the question: find the vector in Cartesian equation of the line passing through. You are given a point, so the point A is given there, and passing through parallel to a vector. This should be cap, I cap, j cap, and k cap, right? To write vector equation, you first write what is given in this. So you are given a vector A, small vector A is given. So if it is, the point is 5, comma 2, comma minus 4, so then it's a position vector of this point would be 5 times I cap plus 2 times j cap and minus 4 times k cap. Okay, and this vector B is given as 2 I cap plus 3 j cap plus 8 k cap. So we know the formula, we just derive equation of this line. Equation of this line would be r is equal to vector r is equal to vector a plus lambda time vector b. So this equation should be r is equal to a. We simply write it 5 I cap plus 2 j cap minus 4 k cap and plus lambda time. Simply put the value. So that is your answer. Nothing much is needed. If you know the formula, simply substitute these values there. A plus lambda b. So this is the vector equation. Now then they ask change this in Cartesian equation also. To change this into Cartesian, we are going to do the same thing as uh, we have just done in derivation of this, no? So for Cartesian form, for Cartesian, we are going to simply substitute. R is a general point, so its position vector is xi cap. Always R would be xi cap, xyz, no? General point, and plus zk cap is equal to 5 I think this is the equation. In place of r, we are writing this. And if we bring the coefficient of I together, see, one is here, another is here. So how will we write it? We can write 5 plus 2 lambda. 5 plus 2 lambda I cap. Okay. And then 2 plus 3 lambda. 2 plus 3 lambda j cap. And then minus 4 plus 8 lambda k cap. Now this is equate their coefficient. If these two vectors are equal, their component, I component, should be equal to the I component on the right. J component should be equal to the J component. So we would say x is equal to 5 plus 2 lambda. This will give you, see, x minus 5 equal to 2 lambda, or you can also say x minus 5 by 2 is lambda. Yes, you get the value of lambda. Now, if you take the y looks like y is equal to equating this coefficient 2 plus 3 lambda. 2 plus 3 lambda. It means your y minus 2 would be 3 lambda, or you can say y minus 2 by 3 is lambda. And finally, your z, which is equal to minus 4 plus, here it is, z is equal to minus 4 plus 8 lambda. So z is equal to minus 4 plus 8 lambda. Z plus 4 should be 8 lambda. So you can say z plus 4 divided by 8 is lambda. You get the values of lambda, you simply equate them. That is your Cartesian form. Let's create some space here and write our Cartesian form. Yes. So our Cartesian form is going to be, yes, x minus 5 over 2, x minus 5 over 2 is equal to y minus 2 over 3 is equal to z plus 4 by 8. All right, so we have written our equation in Cartesian as well as vector form.